Hello engineers, good morning. Let me introduce again. My name is Eddie Hong and I'm responsible for the technical support of nGen. First time we got the webinar regarding reinforcement concrete structure design. How was it? Isn't it beneficial for you? I hope so. Today it is the second nGen webinar in Poland. Today's topic is to train on steel structures as announced in advance. This is the table of contents. First, let me give you an release note which is introducing new features, the latest version. Next, I will talk about the quick basic steel structure tutorial and explain the automatic generating structure drawing. Lastly, we will have Q&A time on that topic today. I will tell you about these new features. This page is an introduction for the features of the drawing details. This feature was already explained the first webinar, and then automatically generates detailed drawings of rebar for beam, column, and walls based on Eurocode. Among the features added in nGen 2020 version 2.1, the most important thing is to add the foundation and underground structures for design. This page explains the isolated footing, strip footing, and mat foundation. It is possible to design with the latest code. These members are supported both generating reports and drawing function. These functions can be used without purchasing an additional option. Let me explain the part of modeling the isolated footings. It is semi-automated to create foundation members. Select the column member and set on the X-Y direction width. You can automatically generate a rectangle, circle, and heptagon shapes. We can analyze two types of foundation methods, finite element analysis and rigid method type. Strip footing can also use semi-automatic modeling techniques. Of course, you can apply modeling and analysis considering eccentricity from the center axis. This is the description of the design settings for the foundation members. Among the serviceabilities items of the foundation member, you can review the bearing capacity, overturning, and sliding. You can also set the rebar arrangement and design review items for each member. This is the pile arrangement feature that I personally think it is very powerful function. This is very useful for reviewing the pile foundation member design. From modeling to pile arrangement, various functions are provided. When arranging piles, both the distance from the end of member and the spacing per pile can be considered. In this version, members have been added not only for the foundation but also for pedestal, footing girder, and basement wall. All of these members are also provided with design functions. When designing on basement wall, all elements can be reviewed. Design grouping and additional lever functions can be also applied. Since the design functions of foundation members have been added, load combinations has been modified regarding Eurocode. Load combinations were added to review the serviceability of foundation, and the existing fundamental tab was further divided into set concept. In addition, as you can see in this figure, a function that can be applied by assigning the desired load combination for each member. The orthogonal effect, which can apply the 130% rule to the seismic load, can also be automatically considered when creating a load combination. Seismic design functions was added so that the review can be checked for strong column and weak beam. We looked at the features added for the latest version. We plan to release interface with Revit program on December at the end of year. When the feature will be released, we will update a release note on that homepage and program. You can check the release notes by clicking on the first screen when you open the product. From now on, let's start the main topic of today, steel structure training. This tutorial goes a little faster. However, if you practice the program repeatedly afterwards, you will be able to apply steel structure using nGen. This is the graphic of the final modeled structure. Structure design overview. The design code is applied to Eurocode. It is 4-story structure with other height of each floor. The member is composed of column, beam, and brace. So this structure resists lateral stability provided by bracing. And this structure consists of non-composite steel framing. The loading details are shown. Self-weight of frames and window load are automatically applied on structure. Dead and imposed load almost applies floor load type. Today, I will emphasize on the window load calculation in nGen. So I prepared 2 types of applying window load about open structure type and enclosed structure type. This is the configuration of the program. Main menu, toolbar, worktree, property window, navigation tools are essential using items. These functions are very often used. Description of basic software operation. Navigation tools are used very often for every action. You can perform various actions while using the program for the first time. First, it is a method of saving other name. Second, set the auto-save time. Third, set the default graphics options as follows. This setting is for optimizing the rendering speed of the program. This is a description of snap point settings. I will explain this part once again while modeling. First, please check how to set snap point on status bar. Okay, let's get started from modeling. On the Structure tab, click the Define Modify icon. In the UI at the bottom, set the X, Y, and Z direction as shown in the screen. Input 6, 5 in X direction and input 5 and 5 in Y direction. Lastly, input 3.5, 4, and 4, and 0.5, 1.0 in Z direction, then click Apply icon. Change the model view as front and make column members using the grid. Click Convert into Member function. Set the type to column in the UI at the bottom. The sections which you see now are the default provided by program. I'm not gonna use these sections, so I will delete them and create a new one. Right click on the section menu, then click Add. When the section template dialog box appears, change the code to UNI and select IPE 200. We will also add the material through the worktree. After selecting EN05, add S235 and S355 added to IDs 3 and 4. Now, after setting IPE 200 as F355, apply. Also, IPE 220 section apply. And set to HEB 220, HEB 260 and apply. Finally, we will add a 110 times 10 S235 L-shaped steel to be used as a truss member. Check the list of sections added finally in the worktree and close the Define Section tab by clicking the Close button. After running the Convert into Member function again, apply the HEB 260 and 220 sections to create the column member. If you select the grid and apply, the members are automatically created. At this time, we will create a beam member. After changing the type and selecting ID2, IPE220, select the grid corresponding to the order to create the number. You can create through the spacebar without clicking on Apply. To check the modeling, right-click after selecting beam members, and you can show or hide the selected members. You can also turn the grid on off through the right-click context menu. At this time, we will create a sub-beam member. On the main menu, click the sub-beam icon, not the beam member. Section is IPE200. I recommend modeling method is using the spacebar and ES keys on the keyboard as if drawing on AutoCAD. Now I am separately modeling a sub-beam each member. I'm going to draw it on the upper floor at once. You can see that the sub-beam members are automatically divided according to the transfer order, even if they are drawn at once. Please note that if you model at once, the ranks of the member may be different depending on whether the member is beam or sub-beam. Next, after selecting the girder member, copy it by clicking Ctrl+C shortcut on the keyboard. To make a copy, take a snap point twice. First, click the snap point where the selected member are currently located. Later, click on the location where you want to copy. At this time, we will create a brace truss member. First, select the section as L-shaped. Before modeling, I will explain how to set snap point. That is status bar at the bottom right of the program. If you click on the first icon, you will see the following screen. Turn on off only the snap point that I need for modeling. It is the same as AutoCAD all-snap functions. Now, click the snap point of truss member as shown on the screen to complete the modeling. In this case, if you use the spacebar and the ES key properly when performing continuous modeling, you can easily model. Quickly complete the rest of the members. use Ctrl+A shortcut keyboard to hide all members. The roof floor is not flat and is intended to be modeled as a truss dual-pitch type. First, we create a truss for the vertical member. At this time, you can set separately for X, Y, and Z direction. And copy the full vertical truss member. Next, change the strong and weak axis for the created truss member. In this case, change the rotation setting from 0 to 90 degrees in the section offset of the property window. Next, I will explain how to change the length of selected member. If you select the column first, a total of 3 sub-points are visible. If you move the mouse near the center point, you can see and select yellow. If you click the yellow sub-point in a state, you can move the selected member to the desired position. And if you click the sub-point of the end in the yellow sub-point state, only the position of the end can be changed. I will make the height of the column member 1 meter higher in the Z direction. I will increase the height of 1 meter in the same way on the other side. Complete the remaining sloped beam member. Then copy the selected members. Be careful not to overlap the copied members. It is convenient to use a shortcut when copying members. The transverse girder is also complete. When the shortcut key Ctrl+H is applied, the section thickness of the section is turned off. Click the Check Model icon on the Member tab to determine whether modeling is abnormal. Check Model function judges whether there is an abnormality in modeling. And if there is nothing displayed by clicking the checked button in the dialog box, the modeling was successful. Finally, show only the roof floor members to complete the truss members. Modeling seems to be complete without any problems. Right-click again in the View window. Grid information can be shown in the View window by clicking Show Hide All Grid Sets on the context menu. Mouse over the section on the Tree menu shows the highlighted members. And you can turn Grid on-off from the Tree menu as well as the context menu. This is the end of modeling process. Today, unlike the first webinar, I tried to make the model by applying a grid information. Regardless of the type of structure, I recommend that users apply more efficient modeling method. Of course, you can just model without applying tracing or grid method. We are gonna to create story data. Structure tab on the main menu, click Story Data. Click Add in the dialog box and click the OK button. At this time, it is used to automatically generate story data, so click Generate Story Data. Select all members and click OK. Story data has been created. If you don't need 6 flow data, click Delete Story Data only to remove it. When it is confirmed that it has been removed, click the OK button to finish creating story data. Next, we will modify the name of the level data on grid. Mouse right-click on the level plan of the grid item and click Modify. After clicking the L icon in the dialog box, modify the name from A to F as follows. You can check the modified level name in the View window. And you can check the number of members for each modeled member type on the Tree menu. Check only the sub-beam members and then select the members. In the Properties window, modify the beam and release type to pin and pin for the selected members. When it is in the pin release state, it will be shown in red symbol at the end of the member. From now on, let's assign the load. Define the load set for the first time. On the main menu, Define tab, click Load Set. In the dialog box, set dead load and live load to different names as shown in the screen. At this time, the wind load will not be set, because the automatic set function will be used when the wind load is input. Next, go to the Load tab and assign the set flag. In order to design conservative in the dialog box, I will add 10% regarding scale factor by inputting -1.1. The next step, click Flow Load and assign dead load and live load on each floor. In the dialog box, load type is absent, so we add it. On the floor load type dialog, add settings as shown in the screen. At this time, be careful of the unit system. flow and loop load type was added. We go into story mode and assign flow load. Select second floor and click snap point to define two-way flow load. Next, go into third floor and define the two-way flow load in the same way. You have to apply the plus button or OK button to finish flow load at the bottom of the dialog box. You can check the input value of the load by clicking the 1.0 icon on the mini toolbar. In order to exit the dialog first and assign the loop flow load of the loop flow. So show only the loop members. Select flow load again. After changing to one-way type, we will set up flow load area. Click the Add button in the area and click the snap point in order. At this time, please note that the one-way load direction varies depending on the order of clicking the snap point. If you set the close area, then press the spacebar or Enter key on the keyboard. Check whether the final input load setting is correct by checking on/off in the worktree. Right-click in the View window to display the context menu. Click Show Hide All Labels so that only the modeling view remains. Next, click Beam Load to input the finishing material load of the wall. Select the corresponding members of second and third floor. To deselect member, holding down the Shift key and selecting the member again. After input minus 8.0 kN per meter, click the OK button. Next, we will assign the wind load. Click Wind Load function on the main menu. Click the Design Wind Load Add button to enter the wind load function based on the code. When selecting the Eurocode, we provide the Poland code as the national annex. First, before assigning necessary information for wind load, we will check the width, depth, height, loop slope degree in the modeling, and then input the function. In the main menu, Member tab, we will use the Measure function to check the sum information. B is 10 meter, D is 11 meter, height is 13 meter. Add the body line to check the slope angle of the slope. Since confirmed, we will return to the window load function and input the information. H is 13 meter, terrain category is 2, basic wind speed is 22 meter per second, and these factors are all 1.0. In addition, the necessary effects for the building structure are checked on if you are necessary. Structure factor provides automatic calculation by calculation formula. But we will use the value proposed in the code 1.0. Click Auto Calculation so that the pressure and force coefficient values can be calculated automatically. Input B and D and slope information you checked earlier. For loop type, select dual pitch loop. If you click OK in the dialog box, the coefficient value will be calculated automatically. In this case, please note that the value is calculated and provided by linear interpolation. It can be divided into structure and roof and subdivided into windward, leeward, and side to check the coefficient. If you click the report function, data and information required for window load calculation, number 11 shows the wind pressure for each height calculated in the graph. Since the input of the window load function has been finished, we will set the window area to finish the window load. Click the main menu, Assign Window Load. The input method of window load is largely dependent on the 4 types of structures. First of all, on this structure, the members on the first floor will be assumed to be open area, and second and third floors will be enclosed area. In order to input X and Y direction at the same time in the dialog box, check on the Generate Load Set option. There are one and two ways of the load distribution. The two-way method will be distributed both columns and beams, and the one-way method resists the window load only the column or beam. In this webinar, we will assume that the column member will register wind loads in a one-way. Therefore, word direction of one-way is set to vertical. Direction is set to global x direction. Define the area as wind load and leeward in the global x direction. At this time, orthogonal modeling option shortcut F8 in the status bar is set to check off. Set the opposite direction about leeward area in the same way. Next, we will also set the area for the global y direction. Each area can be identified by color. Finally, set the roof area. Internal pressure is not considered, so select the None type. Since the scale factor will be defined for the x and y directions at once, set it to 1.0 respectively. The final load has been assigned. The wind load was replaced by a beam load with a column member. And the x and y directions were defined at once. The wind and orthogonal direction are all considered. Next, we will input the wind load to the column at the lowest level as the open structure type. Likewise, assign in global x and y directions at once. Select 9 columns on the select object. Also, for orth direction, select 9 columns as well. Direction, wind function, and scale factor are set identically. If you click the OK button in the dialog box, you can see that the beam load is assigned to each column. If you look at the worktree, set 1 for the x direction and set also direction for the y are set. You can check the enclosed type and open type as sub-items. Check again through check on off on the worktree. Changes the rotation of the middle column members to register wind load well. Go into the top view, select the columns and change the rotation to 90 degrees. You can see that the strong axis has been changed. All of the load inputs have been completed. In addition, I will introduce more roles that can be applied on this structure. First, the snow load. The snow load is provided so that it can be defined automatically based on the Eurocode. You can set the roof type and assign the design-based load. We also offer national annex in Poland, so you can use it. And it's about the imperfection load. Eurocode load is provided and coefficient is calculated automatically, so it is easy to apply load. There are two types, general and building type. Of course, you can set additional load groups to be considered along with the imperfection load. Set the boundary condition to the fixed support at the bottom. We will not model the foundation today, but you can consider them together. Now, set the load combination. Click the steel icon and the load auto generation button. The template dialog box opens. The Eurocode load combination template consists of 7 tabs in steel structure. Create including the envelope data. Let's look at the load combination option. This is a check option to use a template. For wind load data, the X and Y direction are set to group and are automatically generated about load combination. If the user input the X and Y direction respectively when assigned the wind load, this group setting is not saved automatically. Loop option is used when you want to use each load factor in one load type. For example, if self-weight and flow dead loads are set to load group, the two load types can use different load factors. Special size mill option is used to set the 100%, 30 effect or RSS effect. And you can set it to automatically consider the factor for variable action on the Eurocode. In the category, you can select apply the one that corresponds to the structure. Here again, the Polish code is provided by the national annex. Clicking the Add button on the template to create a load combination. If you select the created load combination, you can check the load combination data on the right side and edit the type or factor. And you can click the spreadsheet form to modify the entire load combination like an Excel sheet. Now, let's do the analysis after adding the load combination. All loads are checked on, press the OK button. Click Run Analysis and press the OK button to perform the analysis. An error message appeared. In the sub-beam, it seems that beam and release has been duplicated. Go to the release content of the worktree and delete set 2 and perform the analysis again. analysis was normally performed. When analysis is finished, Analysis Result tab is added. Right-click on the combination content at the bottom of the work tree. If you click Combination, you can check the analysis results you want to select from among load combinations. I will select Envelope and check the results. Before checking the analysis results, check on the member axis on the mini toolbar. Only the second floor members will be explained by Show Only. Click the generation icon of shape offset to set the offset for all members. Let's check the offset status by showing only some members. Check on the shape offset view on the mini toolbar. When you select a trust member, the analysis center line appears to be shared with the column. However, you can see that the shape of member is on the flange of column. All information about this shape offset can be checked and modified in the property window. You can set the file proofing function. Section offset is set to center top, and there is a start offset item. The cutback size is 151.6 mm. At the bottom, you can see the end offset. Since the end of the brace is in contact with the sub-beam member, the reference member is made of sub-beam 5. Start and end are determined according to the x direction of member axis. Let's modify the start offset value. You can see that the start offset was changed. Construction shape offset changes, but the center line for the solver remains the same. Cutback options can also be modified. When modifying this detailed construction shape, use the property window. Perform analysis again. Let's check the bending moment of the beam member. Double-click the item in the worktree. Only one member is shown only in the context menu. The member force of 1D member or 2D member in nGen is all expressed based on the member axis. Next, I will talk about design. In the analysis results, no significant errors were found, so we continue to design. First, set design setting. The structure supports the XY direction due to the brace. Go to the Steel tab in the dialog. Various parameters for strength check are automatically calculated in the program. Of course, if you modify it with user-defined, you can input it manually. To check torsional strength, change the option to considered. Fatigue check modifies the setting as not considered. Let's go to the checking control tab. For efficient, optimal design of steel frame, you can check and change the strength ratio setting. To change the category of OK, change the mean value from 0.6 to 0.4. You can see that the category of need check has been changed from 0 to 0.4. Create design group. The design group is very important because it is used to design result and generating drawing. It is automatically generated by using the auto-generate design group function. Now, do the design. First, double-click the status of total status. To check the result of each member type, go to the Tree menu Model tab. Only the beam member is checked on. The beam member was found to be NG on the second and third floor. Next, if you check only the column member, you can see that it turned out to be OK. It became not good for the sub-beams on the second and third floor, since all of the brace members have been identified as need check, so the size of the member may be reduced. Let's check the table to see what caused the not good. Check the design result in the table tab of the worktree. You can check it with total design result, but if you check it with still result table, you can check the cause of result in detail. At the top, the options are modified by all, design group, and not good filter. On various items, you can see that all not good are generated in the bending content. NG members appear as an IPE section. It seems to have to change the section. NG is seen on several groups in the deflection categories. To modify the NG member, please open the Edit dialog command. In this dialog box, design data can be edited by typing text. modify filter to not good. Check on the entire group to modify the member of all groups. And the SG1 group is modified to HEB220 section. Use Ctrl+C and Ctrl+V shortcut to copy and paste all. Click the redesign for checked list at the bottom right of the dialog box to redesign. After redesigning in the status category, all of bending has been changed to be OK category. And you can see that some groups still have not good for deflection. In the Still Design Modification dialog box, click the OK button. And finally, click the Update icon on the main menu. List about the information of the changed members. When you click the OK button in the dialog box, both the analysis and design results disappear and the members change. On the main menu, Design tab, click Run All. Click the OK button to perform analysis and design simultaneously. Analysis and design are finished. If you check the status for strength again, you can see that the design result has changed. This is the end of webinar prepared today. How does it compare to the last RC structure webinar? I hope that the twice webinars helped you to use nGen. And please pay attention to your health. The third webinar will be performed at 7th July. The webinar subject will be Midas drawing tutorial. At that time, we ask for your continued interest and participation. Thank you very much. Have a nice day.